Okay, welcome everyone. It looks like we've got a good crowd of people here already. We're gonna go ahead and get started. Hopefully you can hear me and see this slide here. All right, hello and welcome to Science Stories from Palomarin. I am Kristen Dybala, Principal Ecologist at Point Blue Conservation Science, and your host for this webinar series. Today, we're presenting episode 2, Tracking a Changing Climate. And we're gonna have some fun today. We have 3 great scientists lined up to talk with you. Before we dive into that, I wanted to set the stage a little bit. If you're new to Point Blue, welcome. We're so glad you're here today. We are a nonprofit science organization, and our mission is to advance the conservation of birds, other wildlife, and ecosystems through science, partnerships, and outreach. And our work stretches from the Sierra Nevada out into the Pacific Ocean and the Farallon Islands, and from Alaska to Antarctica. This webinar series is focused on the Palomarin Field Station, which is located in the Point Reyes National Seashore, about an hour north of San Francisco. And Palomarin is very much the heart of Point Blue. It is our original headquarters and has been an active field station year-round for over 50 years now. And it's where many of us have trained to become the conservation professionals and scientists that we are today. Palomarin is normally open to the public for visitors, but of course, for now, we're closed to keep our staff and interns safe. But to help make Palomarin a little more accessible to you all, last summer we launched the Palomarin Field Station Data Explorer, which is a series of interactive web pages where you can dive into some of the most important science stories emerging from our long-term research and learn why it's so important that we're able to continue collecting those data. You can find the Data Explorer at pointblue.org/Palo Data Explorer, and we hope you'll visit after today's webinar if you haven't already. So in this webinar series, we're exploring each of these major science stories even further in conversation with the scientists and partners who've contributed to them. So today's webinar is focusing on climate change and specifically how climate change is affecting birds. So if you attended our first webinar a few months ago, we talked about the estimated loss of nearly 3 billion birds across North America since 1970, and how there are likely multiple causes of those population declines, including climate change. So today we'll dig deeper into the details of what we're seeing at Palomarin, specifically changes in migration timing and body size. We are saving some time to answer your questions as well. So if you're joining us in Zoom, you can submit questions for any of our speakers at any time using the Q&A button at the bottom of your screen. And if you run into any technical issues with Zoom, this webinar is being recorded, so you'll be able to watch it later. You could also try joining us in our Facebook live stream, or we have a tech buddy, Lishka Arata, working behind the scenes who may be able to help. We'll post her contact info in the chat in a sec. For those of you joining us on our Facebook live stream, we'll also be looking for any questions that come through in the comments there, so feel free to ask away. Okay, background information done. Thanks again for joining us, and let's get to it. I'm going to turn it over to Mark Dettling, Point Blue Avian Ecologist and Palomarin Intern Supervisor, who will be interviewing 2 of the lead scientists who've studied climate change impacts on our birds. Welcome, Mark.
All right, thank you, Christy. And yeah, thanks for everyone that's joining us today. I am really excited to be a part of these stories and have a chance to talk with you all about this work we do at Palomarin, which I'm here today out at the field station. It's a beautiful sunny day right now. If you see my eyes going off to the side, it might be because there's like a wren tit or something bobbing around over there. But as Christy already said, the topic of today's science story is tracking a changing climate. And climate change is really one of the biggest challenges we currently face in conservation. And while we think of that overall kind of effect of climate change being global warming, that's kind of the overall effect that increased CO2 in the atmosphere is having. but the resulting effects on regional climates is much more varied. So we might see some regions that have more annual rainfall and others that are starting to get less. We might see the intensity of storms or the length of drought periods increase. And with this variability, it's important to record data on the changing climate variables and the environmental responses that we see in many different locations around the world. And so here at Palomarin, we've been kind of doing that direct monitoring of the climate by collecting weather data for decades, well before climate change really became a concern for conservationists. But you can see some of that data if you go to the Palomarin Data Explorer webpage. And specifically what you'll see is that the average annual temperature and total precipitation data starting in 1976. So it's a pretty cool interactive graph that you can look at. And you'll notice that we haven't seen any strong trends yet, but that doesn't mean that the birds aren't responding. And so this long-term data set is critical to investigating how the climate at the field station is changing. But that's just kind of that direct way of measuring climate. And there are other ways to study climate change as well. And so at Point Blue, we're really interested in the biological responses to these changes. So we study penguins in Antarctica, seabirds on the Farallon Islands, and songbirds in the Sierra Nevada mountains and here at Palomarin, with an eye towards how they react to those changes in the environment. And so with decades of data, we can begin to answer questions related to climate change. We look back at the data, at our data sets, to see how the species have responded to certain climate conditions. And then we use different climate models that will help us predict the regional climate in the future. And we can make these educated estimations on how the populations of a particular species will react or change to those predictions. So today we're going to have a really great chance to talk with two scientists about two studies from Palomarin data that are highlighted on the Data Explorer website. And again, encourage you to go take a look at that. And I'll start off, talking kind of one-on-one with each of them. And then as Christy said, we'll have a chance for audience Q&A. Please add those at any time into Q&A or in the Facebook comments. So the first study we're going to talk about is how the timing and arrival of arrival and departure of migratory birds is changing and we'll be speaking with Nadav Nur. And before we bring Nadav on, I'll take a step back and explain how this is connected to climate change. So we know that birds need certain resources to survive. Plants and insects often are a part of that. And so many plants and insects take clues from their local weather to drive the events in their life cycles that take advantage of optimal conditions. So for example, we might have a plant that is triggered to flower after several days with high temperatures over 65 degrees. Now, if those first warmer days of the spring are tending to happen earlier, then those plants in that region will tend to start flowering earlier. And this same concept can drive changes when certain insects emerge or when some plants produce seeds or fruits. And our songbirds rely on these plants and insects as food resources. And the events of a bird's life cycle have evolved to coincide with the availability of those certain resources. And so one of those big life cycle events for a lot of birds is migration, and arriving on their breeding and wintering grounds when the necessary resources are available is very important. So the plants and insects, they're going to be reacting to local conditions, but the birds may be thousands of miles away and have to rely on their genetic programming to tell them when to start migrating so that they arrive at the right time. Now, if climate change drives the plant and insects to change the timing of their life cycle events, we don't know if the migratory birds can evolve fast enough to keep up. This could result in a mismatch in timing and have negative impacts on the birds and could result in larger changes in population size. So knowing that information, what Nadav and other Point Blue staff did is they took a look at the decades of our data to evaluate if migratory birds were changing the timing of their arrivals, possibly in response to those climate-related environmental changes. And so first of all, they looked at 3 species of neotropical migrants, and those are birds that spend the winter to our south and breed here locally. And they found of those 3, 1 was arriving earlier, 1 was arriving later, and 1 hadn't changed its migration timing. So a pretty varied response there. They also looked at 4 species that breed further north and spend their winter here. We call those birds temperate migrants. And of those 4, we saw 3 of them, they were arriving earlier, and 1 hadn't changed its timing. And so these results do suggest that birds are adapting. And again, encourage you to go to the Data Explorer website and you can take a look at these results for the individual species that we were able to do the analysis on. And yeah, and so now we're going to get into a conversation with Nadav. So I want to ask Nadav to bring himself onto the screen. Nadav Nur started with Point Blue in 1989 as the organization's first quantitative ecologist, and he is currently the director of our quantitative ecology program. And he has worked on a wide range of projects throughout Point Blue during those years. Seabirds on the Farallones and throughout the Pacific, penguins and seals in Antarctica, elephant seals on the Farallones and whale migration, land birds in coastal scrub, snowy plovers on the beaches of Central California, songbirds in the riverine forests of the Central Valley, as well as the rails and marsh birds of San Francisco Bay and the Delta. So a ton of stuff that Nadav has had his hand in. And we're lucky to have him with us today to talk about this recent work from Palomarin, which I think is probably his favorite data set. And so with that, we've got Nadav on. Let's make sure, there he is. Great, he's got his mute off. Welcome, Nadav.
Thanks. Can you hear me okay?
Yeah.
Okay.
So yeah, like we said, you've been with Point Blue and the Palomarin Field Station for quite a while. And we're just curious if climate change has always been a focus of your research or how that has evolved over time.
Yeah, that's a good question. As you said, I've been around for a while and done many studies. I'd say for quite a long time, we've looked at the effects of climate in general for seabirds and land birds and so on. It's more recently they're really looking at the climate change aspect of it. But climate is very important for birds in terms of their life cycle. And so, for instance, I just mentioned that one of the studies I did earlier was to look at the effects of the weather, looking at temperature and precipitation, important components of climate, and looking at those effects on the breeding success of the song sparrows at Palomarin. And so we did find, for instance, that with less rainfall, then there was a shorter breeding season, so less time for them to be breeding. But then more rainfall, found that was also positive for the birds as well. So that's one aspect, and I would say that more recently we're looking at climate change, and I've done a few studies have looked at it, and for the most part we've looked at the future impacts that really concern what's going to happen in the future when temperatures are going to increase globally and sea level rise and so on. But what's kind of interesting about the study we're talking about today is to look at, do we see any signals today,
Right.
currently so far? And it certainly seems to indicate that there are some of that for these migratory birds. So yeah, that's what I think is interesting about this work. We still want to look ahead to see what the future impacts are.
Right. And so speaking of that study with migration, were you surprised? So as in my short little summary, there were some birds that changed their timing and some that didn't. And were you surprised that some species were apparently changing that migration timing? And why do you think that might be?
Yeah, that's all good questions there. The fact that there was variability among the species, that's probably not so surprising. As you were mentioning before, we had 2 groups of species that were looking at the arrivals. Those that are breeding elsewhere and then coming to Palomarin for the winter, they're overwintering. And there were a number of species, 4 species that we looked at. But then also looking at the species that are breeding in Palomarin, and those are the ones that were overwintering in the tropics. And so the fact that there was differences among maybe those 2 groups isn't so surprising, but as you said, we saw further differences within each group. Sometimes there was earlier arrival, but then there was also one case of later arrival, and then some species that didn't change. So there's that variability, and I think it really points out to what it is we don't know and what it is we need to be following up on. So we're seeing some kind of signal, things are either changing or not changing. I think one thing to keep in mind is we don't know if this change really is good or bad. Maybe for some people they think, oh, change for these species, maybe that's bad, it's disruptive. Um, but it might not be. It could be quite beneficial, what we're seeing. And then conversely, the species that aren't changing, that could be a concern. Maybe they're not able to, they're not plastic enough. They can't modify their behavior. So that's a concern. So I think that's what we really need to be looking at and we're just getting started on that, to look at what those the causes of that variability, and then also the consequences. But I'll start saying with the causes, we're looking at especially where they're departing from. So it would be conditions, maybe in terms of why are they arriving, let's say earlier or later. What are the conditions, environmental conditions on, let's say, the breeding grounds for those birds that are coming here and overwintering? That would be one thing that this could be indicating, but it also could be indicating what's happening on the stopover grounds as well. They could be taking longer or a shorter period of time, being able to migrate faster and therefore arrive earlier. So those are things we might be looking at the causes. And then the next question is really, what the consequences are. And I think that's something that we, need to follow up on. But these signals we're seeing is giving us indications of what to look for.
Yeah, for sure. And that's kind of what, one of my next questions is thinking about what these results might mean for bird conservation in this climate change context. And yeah, I think one of the things that I think about when we look at this research is again, that thing I mentioned earlier, a mismatch in timing. And if the birds aren't able to kind of respond to changes of their environment, then that's going to be a big challenge.
Yeah, I think that is the question. What does it mean? And like I said, we're really getting started on that, looking to see whether this change that we're seeing is really adaptive or not, and if is there a mismatch, like you said. I think for one thing, for the arrival dates, this is where we need to think beyond just the arrival date. I mean, that's just a signal that we're seeing, but we need to look at the step back and look at the life history. What's going on, and this is where we're looking at not only laying date, and so the arrival date, if you're breeding, the birds that are breeding at Palomarin, there's going to be a correlation between the arrival date and when they're actually laying, and that's an important determinant of the reproductive success. So what we really need to look at is what are the consequences in terms of the reproduction, the reproductive success. I mentioned, for instance, the length of the breeding season might be one factor. But then also look at survival impacts, if there are as well, of arriving later, let's say breeding later, or if they're departing. It could be a later, a later arrival could mean a later departure, so that could be a concern as well. So I mentioned that we've looked at the effects of the weather, of temperature and precipitation, which we know are going to be changing in the future. So I've started to look at that. And one study I'll just mention that I did with colleagues at Point Blue is to look at the tidal marsh song sparrows and to see what are the impacts for their reproductive success, and trying to model what the future impacts of the climate change would be. And the results for them was that we found with increasing temperature that the survival of the young was in the nest was higher, but also we found that with the precipitation was also a concern, and with less precipitation, let's say due to drought, then their breeding seasons were shorter, so they had fewer attempts to be able to rear young, to successfully rear young. But also, speaking about the climate change, there's sea level rise to consider. So found that they were strongly affected by extreme tides. So it's kind of king tides that we see both in the spring and summer. So those are what we need to be looking at in terms of what are really the consequences of the future climate change. And I would say, just to wrap up, we're really interested in how we can keep these populations as robust You know, how can we help them buffer the effects of climate change and really make them resilient, be able to respond to these changes in the environment?
Yeah, it's really interesting, and it's really awesome to see how this research can dovetail into that real conservation, real world conservation. So yeah, thanks Nadav. That's again our start little quick intro where I get to ask Nadav questions, but now we're gonna switch gears and speak with Rae Goodman-Lucker, but also remember that you'll have a chance to ask Nadav and Rae questions. So again, keep those coming in the question and answer button. And yeah, so we're going to now switch gears to the other bit of research that is highlighted on our Data Explorer, and it's the master's research of Rae Goodman-Lucker. And her research mined our data to see if the birds in our area might be actually changing their size in response to global warming. And this may sound a bit bizarre at first, so I'll try to like step back and give a little background as to how that comes together. So in ecology research, there was an observation that animals at higher latitudes, so closer to the poles, tend to be larger. And this observation became known as Bergman's rule. And sorry, I lost my place a little bit here. And the ecologists, after seeing this rule, have been trying to come up with hypothesis as to why this might be the case. And one of those leading hypotheses is the ability of an animal to thermoregulate. And so that's the ability of an animal to control its body temperature. And so this hypothesis states that it's easier for larger animals to stay warm than smaller animals. And so the animals are larger in colder climates. This is kind of just an observation and trying to figure out why that might be. And then so in recent years, researchers thought to apply this hypothesis to animals under our current global warming, with the idea that if body size was driven by temperature regulation, then a warmer climate would result in animals getting smaller. So that's kind of a theory that some scientists had. And so armed with data from Palomarin and the San Francisco Bay Bird Observatory, Rae looked to see if our birds were indeed getting smaller. And she used two measurements that we take on all of the birds that we band here at Palo, so our banding operation. One is wing length, or what we call wing chord, and the weight. And it turns out that when Rae ran all of those numbers and all of the statistics, that our birds were getting bigger. Now it's a very small change, but one that was statistically significant over the decades. And it didn't seem to matter if the bird was migratory or not either, which was kind of an interesting finding. And then also interesting, other researchers in the eastern United States had done a similar analysis and found that their birds were getting smaller. And so although these two results are contradictory, seemingly at least, the magnitude of the change that both studies found was very similar, leading us to believe that these changes are really happening over these kind of decades time scales. So our birds are getting bigger. It's pretty interesting research, and we're going to have a chance to talk with Rae. And so I'll invite Rae to turn your video on and do a short introduction. All right, Rae. And so Rae collaborated with Point Blue while completing her master's degree at San Francisco State University, and she currently teaches science in the Chicago area. So welcome, Rae.
Thank you.
Thanks for joining us from nearly across the country. Looks like the sun is still up where you are, so that's nice. And yeah, so I'll jump right in. And you conducted some really cool research into body size changes as a grad student. We're just curious as how you wound up studying climate change at Palomarin, and was that your actual original research plan?
It was not my original research plan. I actually started graduate school at San Francisco State University with not a clear idea what I was going to work on. I had originally joined up with a lab that was working with insects, and then switched advisors to an advisor who didn't have a project to assign me, and she just said, go find something you want to work on. So I was casting about, figuring out what I might do when I was living at the time in Lagunitas, not far from Palomarin.
Mhm.
My then partner, who had lived in Bolinas and spent a lot of time at Palomarin, suggested that I reach out to some of the scientists there and just kind of ask what sort of questions they had and what they thought was important to be researched in the area, and what maybe research questions they'd wanted to get to but hadn't had time for, because I wanted to be working locally and I was interested in working on something with ecology and conservation. So I met with, I think it was Tom Gardali was the first meeting, and he threw out a number of ideas of, there's a project about crows and something else, and then he mentioned there's this data set, and that folks were interested in looking at what effects there was, climate change was having on the birds. And he mentioned this idea about Bergman's rule. And at the time, we sort of all assumed that we'd find what all the other studies would find. And so my question basically started out being, there was the group in Pennsylvania and various others actually around the world, and had shown in birds and a number of other species, including small mammals, that species were getting smaller in response to climate change. And so the original project was look, and we assumed that Palomarin's birds would also be getting smaller in response to climate change. And that's kind of where it all started off. Was I thought this was just going to be a pretty straightforward analysis, working with, the question that Tom had suggested.
Great. And so I having worked here at Palomarin, I know that, the data set is quite large and can be unruly. And so I'm wondering how you approach these decades of data. And then, kind of following up to that, like, were you surprised by then what you found with the analysis?
Yeah. So I first, besides just sifting through, I was handed, exchange. We worked out, data exchange, and I actually did some work, helping collect future data in exchange for the data. And but basically, I was handed this enormous, incredibly valuable data set to look through it. And so I started sifting through it, honestly, just in Excel, looking for how many birds there are, how many species, how many captures.
Mm-hmm.
I started narrowing down to see what would be useful to me, to look for how many birds had been captured enough times over enough years and with enough spread across the years that we'd be able to say, okay, this is a change that's happening over decades, not just 3 years in a row, but over 25 years or 35 years, and enough captures to get to statistical significance for each species. And we made sure that we're only using the first capture of each bird, and only adult birds, so that we weren't comparing youth to adults or other things that would maybe throw a wrench in the data. And then what I did is I sorted it down once I had my data narrowed down, and I just started, running a real basic correlation. I think I was, running the numbers and just putting together simple little graphs so I could kind of see it. And it kept coming up that the birds were getting larger. This species was getting larger, and this species was getting larger. And I was a first-year grad student, working with somebody else's data. And my first assumption was I did the statistics wrong.
Right.
So I did them again. And I did them again, and I ran them by somebody else, and they said, no, it looks right to me. And so I came back to Tom and the other folks at Palomarin and said, look, I think this is what I'm finding. And they checked it over and said, your numbers are right. That's weird. The birds, we have no idea what's going on. And so we sat down and had this meeting. I can picture it, all of us around the conference table. I think there were 5 or 6 of us who all came to the meeting to go, what's going on? Because we just assumed that Bergman's rule had shown to be decreasing bird size at one site after another, and all of a sudden we had something different, and we had to figure out why.
Mm-hmm.
A couple hours bouncing ideas around, could it be this and could it be that? And so I then had to follow up and we'll try this analysis and try that analysis. And like you mentioned, make sure it's not just the locals or just the migrants. It wasn't just the ones who nested on the ground or just the ones who ate insects or just we eliminated a lot of, well, could it be this or could it be that was giving some sort of false signal about climate change. And as we knocked out one thing after another, it kept coming around to the only thing that's left that all of these birds have in common, migrants, non-migrants, different sizes, different life histories, the only thing they have in common is that they are living through climate change.
Mm-hmm.
So although there's no comparison for climate change, it was the only thing that made sense over this time scale to say these birds are being affected by climate change. And then the question became, well, why are they being affected differently than anywhere else that anybody's studied?
Yeah, so do we have any theories or data, or what's kind of the thought there?
Yeah, so this gets into climate change gets referred to as global warming and climate change. And really the difference between those two terms, I think, is what's going on with these birds, where, like you mentioned, Bergman's rule hinges on, as best anybody's been able to figure out, the idea is that it's hinging on temperatures and ability to thermoregulate and maintain body temperature. And that the warmer the average temperature is, or the cooler the average temperature is, that impacts body size. But climate change isn't just warming, it's variability in high temperatures, variability in low temperatures, in amount of rain, in strength of winds, in all these other factors. And so one possibility is that the variability of the weather is actually having more of an impact on these birds. Either because, possibly because they're having to basically survive more extreme weather events, whether that's hot days, cold days, days that you're wet to fly or forage very well. And so being basically big and bulky lets them survive these sort of small fasting periods where they can't forage well. And so being larger helps them get through these tough times.
Right.
The other possibility is that somehow in all of this variability of climate, of different amount levels of precipitation and things like that, that the primary productivity, the plant growth, and in some areas may be going up and in other areas may be going down. So one possibility is that at many locations around the world where birds and other species have been studied, the primary productivity, the plant growth that feeds the birds and feeds the insects that feeds the birds, has been decreasing. You know, we've heard about a lot of ecosystems struggling, but maybe on the California, in the Bay Area and the California coast, which included Palomarin and the San Francisco Bay Bird Observatory in the South Bay, maybe in this relatively dry climate, the particular details of how the climate's varying and how the precipitation is varying, maybe that's actually increasing the primary productivity and the plant growth. So these birds are actually better fed than in other areas. What we didn't see is a signal of local birds versus migrants who would be more or less affected by localized change, being affected differently. So it leans a little more towards, it's something about these extreme weather events and overall climate variability, but it could go either way. But either way, it's something about more of the nuances of climate change is the best we've come up with. Of course, we have, follow-up research. I haven't got studies to show it yet, but that's the direction that everything we found, including looking at the actual climate variability and what's going on, lines up with that's looking likely.
Wow, yeah, it's like super interesting, and I know I could ask a bunch more questions, but I think we're gonna try to switch over to having the audience get involved. Yeah, and just for both studies, one of the things that my take home is that we've got this great data here to give us information on where we need to look next. Science is almost always like a question followed by another question. So I think it's time to have Christy come back on. And Christy's going to go ahead and kind of help facilitate us through the question and answer period. And I think do we want both Rae and Nadav to have their videos on?
Sure, yeah, they can come back on. Yeah, thank you so much for that really interesting conversation. We are going to turn it over to audience Q&A at this point. I'm gonna do a little bit of more background info before we dive into that, just to remind you to please check out the Palomarin Field Station Data Explorer. This is our interactive website that lets you dive into these decades of data. The link is up on the screen right now, and you can find links to Rae's and Nadav's studies and lots of other stuff there too. I also wanted to let you know to make sure you hear about future webinars in this series and other Point Blue events. You can sign up for our email list. You can also follow us on social media, Facebook, Instagram, and Twitter. We do have a live bird banding demo planned for next Tuesday, February 16th, that you can find on Facebook. That would be super cool to see banding live. We're also a nonprofit science organization that relies on donations to support all of this conservation research, our intern training, and our public outreach efforts like this one. So If you enjoyed this webinar and would like to support our conservation efforts, please consider giving us a donation at pointblue.org/donate. We do have some donors attending today who've been supporting Palomarin and Point Blue for decades. So thank you so much. We really appreciate all of your support. Okay, let me look at, we've had a bunch of great questions coming in. I can turn this slide off for now. Let me switch back over here. Okay, let's start with a question for Nadav. Can you tell us a little bit more about, the bird species that are arriving earlier or later? How much earlier or later are we talking, and kind of over what time period are we talking about here? And is there any correlation between birds arriving earlier or later and the emergence of some plants or fruit, Palomarin, or anything like that?
Yeah, well, let's see. What's interesting about the arrival is, in general, we're seeing the earlier arrival for a number of species. I said both the ones that are arriving in the fall and overwintering and arriving in the spring. In terms of later, the Wilson's warbler was a species that was arriving later, but it was not much of a difference, so less so. And one thing I think is also interesting, I'll just mention about these the trends that we're seeing is that they're not necessarily linear trends, and I think it's easy just to kind of focus on that. And we might expect with climate change that we'd see accelerating change. We're expecting more and more of an impact that way, and so we actually did see that. We see an accelerating trend. For instance, for the golden crowned sparrow that is arriving earlier, but more so recently in the hermit thrush. Hermit thrush actually the overall trend wasn't that pronounced, but more so in the recent years. So that's been one of the findings, and I guess yeah, I'd say in terms of number of days, certainly you might be talking about like 10 days earlier, which could be significant. So not just some minor change. Yeah, let's see.
I threw a lot of questions at you at once.
Yeah, I don't know, and also give a chance if Mark wants to talk a little bit about the birds. We have warblers, which are insectivores, and a range of different species in terms of what they're consuming, which is kind of interesting.
Yeah, I can maybe just speak just very briefly about I think there's a question of if we've had other data like about plants or insects. And we started doing some plant phenology. So phenology is basically the study of timing of events. And we started that, I think 8 years ago. Diana is gonna make sure I get this right. But anyway, we started that a while ago, and we're just kind of now getting to the point where we have a long enough data set. And we haven't really dug into that yet, but we will continue to kind of collect that data and see. We chose species that we thought were probably an integral part of at least the Palomarin ecosystem.
Yeah, always more work to do, but yeah, it is a great new addition to Palo's data set, and might be able to even address some of the ideas that Rae brought up about changing productivity over time and how that's affecting our birds. Let's see. I have a question I think I'll shoot this to Mark. Do we use any remote sensing tools to monitor bird migration?
Yes, and I mean, I guess more, there's all the terms have very specific meanings, so I'm not sure if we call it remote sensing, but we have, our main, the thing that most people know about is the little metal tag that goes on a bird's leg, and that's very passive, and you have to recapture the bird, and you only get data every time you capture it. But we do some research with putting little electronic tags on birds. They're still at a stage where we have to recapture them, but then once we get that tag, we can download a bunch of information about where they went, how long it took for them to get there. And yeah, the technology has been advancing quite quickly. Some of the first tags, gave us information where we might know within maybe 100 miles or so where they wintered. But now we've got little GPS tags, and it uses similar technology in your phone, and it'll tell you within like 10 meters where the bird was at that exact time. And so we do have, when we have the opportunities to use some of that technology, we're definitely working on studies to connect our birds to their wintering or breeding locations.
Nice, thank you. Okay, let's see what else we have here. A couple of questions, related questions for Nadav, about how, well, maybe for both Nadav and Rae, is how does climate change affect native and non-migratory birds? And are there any changes we've observed with non-migratory resident species in terms of any new ones arriving or present ones declining? Maybe this is for Mark too, all three of you potentially. Anyone want to take a first stab at that? Nadav?
Yeah, so I'll start, because we actually did, as sort of at the same time, looking at the migratory arrival, and this work was for a report by the California EPA on climate change. So they came up with a report about every 4 years or so. But as part of that, this is where the migratory arrival work fit in, but also looking at the song sparrows and looking at a potential climate change impact. So I did want to talk about that a little bit, which is that we did find, we're looking at laying date. And I mentioned with the, the arrivals of the birds that those that are breeding here, that the migratory birds, their arrival date could affect their laying date. The song sparrows are present year round. And we did find that the conditions in end of February and March affected their laying date. And so with colder temperatures, they had later laying date. And actually in some recent years, that period has been colder at Palomarin, and we've seen a shift to later laying. And that's in general a concern because, I mean, Mark mentioned about the kind of the fit, the match of the prey, but in general for birds, those that breed later often have lower reproductive success. So, yeah, I think migratory birds are really interesting, and so are the resident and the song sparrows. Is one that does seem to be, it's pretty strongly impacted by the weather as well.
Great. Anyone want to add?
Jump in.
Yeah, go for it.
One of the things that I found in looking at the bird sizes is that migratory birds and resident birds were being affected in the same ways and to the same degrees. So one of the things that we did to figure out if this was really effective climate change versus some local effect, maybe there's local pollution or who knows what, was these kind of comparisons to say, what about the migrants versus the non-migrants, the cavity nesters versus the branch nesters, the insectivores versus the seed eaters. And we found over and over again, there was not substantial difference between species, particularly including not a big difference between migratory and resident species. So the residents are being affected, their body sizes are getting larger. And we found that also we split it out by season to see if it was maybe only in the spring that the birds were larger, maybe as a result of fat stores or something about their breeding condition or something like that. And season did not have an effect. And that was including looking at whoever was there in any season, which was year round for the migrants. So it was the same trend of increasing body size all throughout.
It's incredible. It seemed like you sliced and diced that data every way you could think of.
Yeah, I really had to back it up and say, it's not anything else. We tried everything else. It's got to be climate change.
That's amazing. That's amazing. Mark, did you want to add anything to that question? Okay. Okay, let's see. We've got several more here. Maybe I'll direct this one to Rae. Someone suggests that larger males might possess a breeding advantage. So would the climate variability cause of increasing body size get amplified maybe by that breeding advantage? Or was that one of the hypotheses you considered?
So one of the things that we looked at in looking at, could it be this, could it be that, could there be something that was throwing off the signal, was we looked at the sex ratio to say, is this different between males and females? But also, is the sex ratio of the captures different? So maybe if in one species the males are larger, as this person is sort of envisioning, if we just captured more males, then it might seem like the average size was getting larger just because there were more males in the sample over time. But we found that first, the sex ratio wasn't changing in a way that would skew it. And we didn't see a connection between the sex of the bird and the change in body size. So I don't have anything to particularly say that this is particularly happening split by sex, which we might expect if it was conferring an advantage to males, then maybe we'd see sort of a doubling or a, an increasing effect of bigger males become more successful. So there are more bigger males. So we didn't particularly see that. But it's possible something like that's happening. It's just not enough of a signal to be able to pick up on. In theory, possibly, as things change, just like as the bird's timing is tied to the environment, their size might be tied to their reproductive status, either for males or females. A larger female might have more energy and fat reserves to lay and, take care of more eggs. So how it plays out for the birds, we don't really know. One of the things we did look at about how this might affect the birds in their sort of overall life was looking at whether the wing ratio was changing. So as they were getting larger, was it just the body? Was it fat reserves? Was it wing length? And that the whole body is basically getting larger as a whole, the wing and the weight is getting larger, and it wasn't tied to fat reserves. So things like we don't have reason to think it's going to be tied to how they fly or, and it wasn't just how much fat they were storing. Whether it would affect reproductive success, that'd be a great follow-up study to get into. I don't have the answer.
That's one on my list for sure for Palo. Great, thank you for that. We have kind of maybe a more of a statistical question that maybe Nadav could address, which is how many years of data does it take to declare there's a long-term trend, like with migration dates, rather than year-to-year variability?
Yeah, that's a good question. Yeah, as I mentioned, even when we think of a trend, we shouldn't just think about, this linear constant trend, but the variability is a big question, and it seems especially important, I'd say, in marine systems. I think everybody knows about El Nino years, La Nina. If you live in California, you talk about it a lot. So we do have things besides, just this year, whether it's El Nino year and so on. Yeah, I think actually one of the results really is that in some cases, the year-to-year variability in the arrival dates didn't change that much, and there either was or wasn't a trend. In other cases, wow, there's really a lot of variability. So there's a lot to learn about that. But to kind of, take a first stab at trying to answer the original question, well, how many years do you need? Yeah, I mean, I think, especially since we're knowing more about climate, climate patterns, it probably would want to be looking at something like 20 years of data or something. And we have in general have had that or more here. So I think that's good. I think you start looking at just 10 years. Oh, actually, I should mention one thing. And I just to mention is that the study here that we're reporting, with the colleagues at Point Blue that we did here that we've been talking about, there was an earlier study that was done for the Palomarin data, and actually some of the trends that we're seeing now are different than the trends that were seen, closer to 2000 and 2005. So that's another factor too. It's not whatever trend there is, and I did allude to that before about some of the species like hermit thrush that are changing. So that's another factor as well. But yeah, I think we'd want to look at a good a good stretch of years. Like, so I mean, 10 years you probably wouldn't. It's really hard to be able to untangle different effects of with just 10 years of data. So it's great to have 20 years, 30 years.
Yeah, it's pretty amazing to have the length of data that Palomarin has. It's so incredibly valuable, and like you said, yeah, the interpretation can change so much when you're looking at just 5 or 10 years of data versus a much longer time period. Let's see. I have another question for Rae. This is a little bit more about kind of how this experience, your research at Palomarin and as a grad student, how has that influenced or has it influenced your teaching today or your life in any other way, your career?
Yeah, so after I did my graduate research, or while I was doing my graduate research, I ended up teaching and then have been teaching since for about over a decade now. And yes, it influences my teaching. I, for several years afterwards, was regularly every year presenting my research to my students as if I was doing a professional presentation and giving them experience of seeing what what professional research looks like and giving them the chance like this to ask questions and find out what really went into it. In teaching science, often, it's standard to get taught. There's the, observation, hypothesis, methods, research, data collection, analysis, discuss, and conclusions. But really my path was much less linear of, well, I started with the data and then we analyzed it. And then we ran into a question and to let students see that science involves all of these elements, but they can be put together in really different ways, and to see the collaborative nature of science, that it's working with folks at all sorts of different organizations, and to let them see that they can get involved in science in lots of different ways. I try and have my students involved in citizen science, where they're participating in data collection or volunteering with different organizations. And I think he's dropped off the call, but one of my former students was actually on as a participant on this. So I say it's affecting my teaching, but also carrying through to my students. And then the reason he's on the call is because he's considering a graduate studies in environmental science. So it's all tied together.
Excellent. Yeah, that is so important that science is often presented in such a neat package, and that is rarely the actual case behind the scenes. And yeah, we are always kind of circular here in becoming new scientists and inspiring new scientists, hopefully, as we carry this forward. This is so great. Let's see. I think we probably have time for a couple more questions. I have one, just curious for Rae, what after you kind of narrowed down the data from Palo to what was usable for your analysis, what proportion of the species seen at Palo were ultimately represented? How many species did you look at?
Yeah, so I saw that question come in the chat and actually had to go back and look at my own data. It's been a couple of years. But what my notes tell me is that there were 28 species that met the criteria for having enough data. Over 25 years was the window that we decided you had to have a span to count as looking at a long-term trend. And that was 28 out of, at the time, the number I was given was 180 species, I think, had been captured ever at Palomarin. Now that sounds like a relatively low number, 28 out of 180, but keep in mind, those are the species that are the most frequently captured. The 180 might include ones that had been there once ever, whereas these were the ones that had hundreds upon hundreds of captures. They represent a smaller, less than half of the total species, but certainly a large portion of the individual birds that were there on any given day. So I was looking at, in terms of data points, I think it was tens of thousands of captures out of the entire, now I don't know the total number of the data set off the top of my head, but it was 19,000 captures in those 28 species.
Yeah, those databases are large. That's great. Thank you. It's so many. I mean, it's amazing that we could address 28 species. Okay, well, I have one question about wren-tits. We love to talk about wren-tits, and they haven't come up yet today, I don't think. So Nadav, maybe, or Mark, have there been any noticeable changes in populations of the resident wren-tits in terms of laying dates or success or body size?
I can speak to the laying date. We did look, actually a good point in speaking about species. Yeah, I mentioned earlier about the song sparrow laying date, that there's been a change, and we looked and found it was related to the temperature. For wren-tits, we didn't see a change, so there was no trend there. Yeah, so wren-tits are very interesting. We like wren-tits, yeah. So we didn't see that, but yeah, that's a good question. Like, what is it? I mean, as I said earlier, just because you don't see a change, it doesn't mean maybe there is something, to respond to. But I would say maybe one difference I'll mention between song sparrows and wren tits is that song sparrows are very much a multi-brooded species, having multiple broods, and wren tits much less so. And so the whole breeding season is it's important to think about that, not just the single, attempt, let's say. And for the wren tits, it's more there's a single one. So that's why the implications and maybe even what's behind it, could be different, affecting the laying date, because for the song sparrow, they're kind of in it for the whole breeding season. It's a number of months, and the wren tit, in most cases, they'll just have the one brood. But maybe Mark wants to say a little bit more about wren tits.
I think we don't have a ton of time, but just I'll add just information about the population. The number of breeding pairs has changed over the years, and that's really tied to the vegetation change here at Palomarin, which is probably partially, affected by climate change, but I think it's more affected by the historic land use and it going from kind of basically farmland in the 50s and early 60s to scrub and forest at this point. So there's plenty of wren tits still around. They're actually adapting to Douglas firs more than we would have expected, but yeah, they're definitely still kicking around here.
Thanks. Maybe before I just take the last minute or two to wrap up, I wanted to bring in our final question from a viewer, and a question that I was planning to ask anyway, which is to talk about how people can help. What are some things that we can do to help birds adapt to climate change, or contribute to bird conservation and minimizing the climate change impacts on them? And maybe Mark, do you have any thoughts on that?
Yeah, sure. There's definitely things that folks can do. One of those is kind of contributing to these climate change mitigation efforts, and that's often through policy initiatives. So, voting for representatives that take climate change seriously is also, but you might also have other local policies that are very much directly related to conservation. You can contribute your time and your hard-earned money to the efforts that reduce the stressors on bird populations. Restoration projects, creating your own backyard, being bird friendly, keeping your cats indoors, trying to bird safe your home, the windows. That's a big another thing with conservation as well. And so all of these, these are stressors above and beyond climate change. But if we can reduce those, then we give our birds a chance to, an ability to make these adaptations to climate change. And something that you'll hear from Point Blue quite a bit is we use the term climate smart conservation. And you can think about using that idea in your everyday life. And basically, you're kind of, if you have a future decision, you're buying a house or a car or something, you might want to think about the, what the climate change how that might affect that decision. There's an obvious one of like, oh, I'm going to build my house somewhere, and you find out that that's actually going to be an area that's going to be more impacted by floods, or it's going to be an area that's going to be more impacted by droughts. You might think about how that is really, is that going to be beneficial for you or the environment? So that climate smart thinking is something that we encourage.
That's really great. Thank you for that. Okay, we're going to wrap up in the last 30 seconds or so. Thanks again to all of our presenters and to all of you who attended and sent in some really great questions. If you do have any more questions that you're just thinking about now, you're welcome to reach out to us. We'd love to hear from you. Our contact info is up on the slide. And before we go, I just wanted to try to wrap up this conversation with some of the key take-home messages that we wanted to leave with you for how climate change is affecting our birds. And what we've heard today is that climate change affects birds in many ways, physically, in their body size, in their migration timing, and the timing of other events in their lives. on top of changes to their habitat. And our science is helping to track and understand those changes. And what we've heard today is that it's complicated. Not all species are responding in the same ways. Some are going to be arriving earlier, some later. Our birds are getting bigger, others are getting smaller. But we wouldn't know that without all of this long-term data. And there's more work to do. So it's important to continue studying these birds over the long term and understand how these changes are affecting whole populations and their conservation needs. And as Mark just said, in the meantime, you can help by supporting conservation efforts to restore habitat and reduce other stressors on these populations can help create the time and space these birds need to adapt. So there's tons more to study here. And if you are thinking about grad school or you're interested in partnering with us on a research project, we'd love to hear from you. And really for anybody attending today, we'd love to hear from you about how this webinar went. Yeah, so thanks so much for tuning in today and for your interest. I'm really looking forward to the next episode in this series, which will focus on habitat change at Palo and its effects on the bird community. And then the one after that will be about migratory connectivity. So if you're interested in hearing more about those studies that Mark mentioned, be sure to sign up at pointblue.org/sign up so you don't miss it. All right, have a great afternoon, everyone. Thanks again for joining us.